Great morning, everybody. Thanks for this opportunity to present our phase one show and tell from the Modernizing Data Applications. And our project is specifically focused on supporting fuel poor households through data integration and AI. And my name is Simon Tricker, and I'm co-founder of Urbantide. And I'm also joined by Tom. Tom, do you just say a quick hello?
Hi, I'm Tom. I'm the lead data scientist over at Urbantide.
Great. And also Lottie.
Hi everyone, I'm Lottie, a design researcher at Connected Places Catapult.
Perfect. And Matt.
Yeah, hi everybody. Matt James, I work in the regulatory strategy team at DCC.
Great, thanks Matt. And Ellen.
Hi, I'm Ellen Webborn. I'm a data scientist and research associate on the SEARL project at University College London.
Great, and last but not least, Heather.
Hi there, I'm Heather Stevenson, Data Information Manager at the Greater South East Energy Hub.
Perfect, thanks very much. So we'll hear from some of our the organisations that will just introduce themselves as we go through our presentation. So just to give you a quick overview really of what we're, the big challenges that we're really trying to solve with our project. And it's really the key goal of achieving net zero targets. And we're focusing specifically on the need to retrofit nearly 29 million homes, as they contribute nearly 20% of our CO2. There's a great need for energy suppliers and local authorities to help to support those retrofit rollouts, and they spend an absolute fortune trying to identify households that are in most need. And really what we're trying to do is to help support the reduction in fuel poverty. So there's already 2.4 million households that are fuel poor, and that's only growing with the COVID impact. So really in phase one, the kind of key successes that we've managed to deliver within the short program is we've proven that we can integrate a number of different data sets, specifically the integration of the DCC smart meter system data, and to create some new insight on fuel poverty intelligence. We've also proven demand for this new data-driven insight for local authorities, energy hubs, managing agents, and energy companies and other utilities who are interested in using this new insight to help them to better target and to roll out better interventions. We've also really expanded the ethical use and looked at how to sort of really deeply understand the challenges of using this type of data, as well as advancing the use of opening up this type of data with Ofgem's permission to use the DCC data for this specific use case, as well as linking with UCL and SEARL to help to validate our solutions. And we've also considered the consumer perspective, so understanding the benefits from their side, as well as the ethical considerations. So really just to sort of outline briefly on phase one, it's quite a complicated diagram, but I'll distill it down. Effectively, we've really focused on the first side of identification, so bringing together a number of different data sets, developing our analysis, linking with UCL to develop our outputs across fuel poverty, mapping at-risk areas, and developing our final solution. We've also looked specifically around the ethics, larger stakeholder engagement, as well as benefits evaluation, and I'll get into that in a later stage. And then ultimately what we want to do in phase two is then look at what happens once you've identified what are the interventions and what are the potential impacts, and trying to use real-time data to assess that. So really, one of the key components is obviously understanding the user's needs, and we worked extensively with Connected Places Catapult to help to do the stakeholder engagement and really kind of understand their needs. So I'll hand over to Lottie now, who will just take you through some of the work that we delivered there.
Great, thanks Simon. Hi everyone, just so you know, I'm Lottie, design researcher at Connected Places Catapult. So I'm just going to talk through some of the the stakeholder engagement work that we did to support the project. So really the purpose of this was to kind of engage with potential users of an identification methodology or a tool that utilised the data. And I kind of, to start with, to identify some kind of significant organisations in the ecosystem, the different roles they played, what their motivations were, and then also the pain points that they faced from how they worked at the moment in terms of kind of identifying and managing people through retrofit schemes. And then thinking about how a solution utilising that smart meter data could be of value in kind of addressing the pain points they face at the moment. So really the objective was kind of to uncover the insights, develop a series of use cases, and then under the principal use case, develop a set of user stories to kind of inform the development of the solution. Next slide, please, Simon. Thanks. So in terms of methodology, there are kind of 4 approaches we took. As a general kind of overall thing, everything was supported by some desk research, and then we began with some kind of consortium member working sessions to kind of just build an understanding of the ecosystem as a whole, like who were the stakeholders, how did things generally work, and what were the kind of retrofit and fuel poverty, like what did those ecosystems look like, basically. And then that led us to some semi-structured interviews with some prioritised stakeholders. There's a list of these I'll go through and what I'll show in a second, but this was kind of from a mix of local and combined authorities, managing agents, government bodies, energy companies and charities, as well as the Energy Hub. And we utilised the insights out of those interviews to develop a set of process maps, basically documenting the process of identifying and managing someone through a retrofit scheme at a high, sort of at a relatively high level, and looking at for what each stakeholder needed to do as part of that process, and then capturing the pain points that appeared in those process and sort of assigning use cases to them, so that for every use case we could say, this is how the data is going to help address this pain point that someone's facing as part of that process. Next slide, please, Simon. So this is just a list of some of the stakeholders. As you can see, there's kind of different local and combined authorities, a managing agent, central government, charity, energy provider, and the Energy Hub as well. So the idea with this was just to get sort of input from a wide variety of stakeholders and try and see what the process looked like from different perspectives as well. Slide, please, Sam. So this is just an example of the process map that was the output of those kind of interviews. So as you can see, it's a bit of a complicated diagram, but basically this just sort of maps out the process from the points of view of different stakeholders. So this is like a local authority that's been approached by the Energy Hub and then is using a managing agent to carry out kind of the marketing and the delivery of the scheme. So what you can see is that these kind of green text boxes with the dotted outlines, those are kind of the pain points that were faced. So you can see, like at the point where they had to design the retrofit scheme, the managing agent points out it's very difficult to select who to target on a granular level. And then we kind of assigned a use case to that. So saying like the use case, and this was the principal use case, was utilizing that data to better target direct and indirect marketing and improve the kind of uptake per spend on the cost of marketing at the moment. Next slide, please, Simon. Thanks. So yeah, the principal use case really was around that kind of the identification, as Simon already mentioned. And so what we did was develop a set of user stories through the interviews with local authorities and managing agents to understand what they'd need from the solution to help them do that. And so these are just 6 of the main user stories, so include kind of accessing data at a certain level of granularity, accessing it in different forms, so in like a basic spreadsheet, but also say with a map-based visualization, being able to run queries based on the data, and also having continuous access to the data rather than sort of applying through a permissions process. And so yeah, these basically sort of informed the development of the solution. Yeah, next slide. Thanks, Stephen. And so in terms of kind of key users' motivations, this sort of research really pulled out that the local authorities and managing agents were the key users, and really their motivation was to better understand where fuel poverty is prevalent, basically so that when they market the scheme, they get better uptake and they can have the most, they understand where they can market the scheme, so to have the most impact on fuel poverty and on their retrofit obligations. And then I'll now pass over to Heather from the Energy Hub to talk through some of the other key insights as well.
So the Greater South East Energy Hub works with 137 local authorities currently across its area to deliver retrofit. And each one has a sort of slightly different approach to how they undertake their marketing, but it can be quite varied, from things like advertising spaces and bus stops to writing letters to homes where evidence and local knowledge might lead them to believe fuel poor might be found. But it's quite a difficult, given the current sort of scarcity of data around people's incomes and the difficulty in accessing that, to develop a sort of detailed marketing strategy. So we've got a retrofit scheme called LAD2 in flight at the moment, and we're trying to really find approaches that are going to lead us to not just people who qualify for the scheme, but actually also the most vulnerable residents in fuel poverty, so we can prioritise their retrofit as well. Thank you. I'll just hand back to Simon now.
Great, thanks very much. Yeah, so really to conclude the understanding of the user engagement work and our kind of next steps really and recommendations, we really want to accelerate the engagement process, so to help to validate those core use cases, to really ensure we've got them validated from a number of organizations, but we want to confirm that those are representative to a wider number of organizations, so other local authorities and other energy hubs, as well as energy companies. We also want to continue the engagement we've had with BEIS to understand how the market's going to evolve as there's increased rollout of retrofit solutions and the incentives around those, as well as the eco obligations and how that's going to update in the future. So to ensure that we can align with that policy development. We also have engaged with energy companies and networks, and there's some interesting use cases around their local energy planning and potentially using the data-driven insight that we developed as well. So from a data landscape perspective of linking all this different data together, one of the key components of this was really utilizing the DCC smart meter system data. And I'll hand over now to Matt from DCC just to take you through some of that.
Yeah, thanks, Simon. So, I mean, the smart meter rollout's really progressing at a good pace again, and there's many millions of meters now connected to the network across Great Britain. And so that system is enabling around 500 million messages to be sent to and from installed devices every month. At DCC, we don't actually see inside those messages, but what we can see is what's been sent where and when, really. And like many organisations in the sector, what we've been trying to do is find a way to maximise access to that data set, really to help solve societal challenges and particularly accelerate the transition to net zero. And so participating in this project really helped us to understand some of the key issues associated with data sharing, and not least data privacy, ethics, and also regulatory compliance as well. And so to navigate some of those issues, what we've managed to achieve, and in a fairly short time frame, I think it's fair to say, is to share a GB-wide data set with individual records that are grouped by lower super output area. And so just to be clear, that data set contains absolutely no personal information, so it's fully anonymized. And what we've also done is obfuscate the time and date of the messages, so they're randomly generated, but within a 2-hour window. And so whilst that data set is kind of fabricated, the ability to analyze trends and insights really hasn't been lost. And Tom from Urbantide will talk through some of the great work they've done on the analytics side in a little bit. Just a final point there from a regulatory perspective, that there are restrictions in the DCC license that limit our ability to share data in this way, but Ofgem have actually granted us approval to participate in this project as a permitted purpose, which has really helped clear the way.
Great, and I'll just hand over to Alan just to talk a little about the work that we've also developed with CERL.
Thanks. So CERL's contribution was really to establish a proof of concept in order to establish that we could gain ethics approval for this kind of research and to demonstrate the potential to use the CERL data sets for fuel poverty analysis. So we created a proxy fuel poverty risk classification based on a household's reported financial well-being and their EPC rating. And we then use machine learning to predict membership of these fuel poverty risk categories based on EPC input data and on the CERL survey data.
Great, thanks very much, Alan. And we're hoping to continue to work and to develop those models and to support the validation of our solutions as we develop with UCL and CERL. I'll just hand over now to Tom, who will talk through some of the data science development that we've carried out specifically at Urbantide.
Yeah, so we were provided with DCC smart meter data, which comprised of three categories of message. So there's when the household puts money onto the meter, when they move into emergency credit, and when their device is disabled, and so they no longer have access to energy. And we also had access to the IOMD, which is the Index of Multiple Deprivation Score, and seasonal weather data. And we were using this to enable prediction of people who are basically moving into fuel poverty. Next slide, please. So looking at the data, there's a few interesting things already, which is that the number of devices is very heavily correlated with the IMD decile, where lower is greater deprivation. And also you can see a trend in the top-up interval in days. So people topping up at 7, 14-day intervals, or sort of weekly and fortnightly. The next slide, please. There's also a strong seasonal trend, as you would expect to see. So this is emergency credit being topped up on the left and disablement on the right. And you can tell that the big dip there is basically the summer months where there's more light and it's warmer, as well as peaks during December and into the winter months. We just move to the next slide. And so we took the top-up messages, the emergency credit messages, and the disablement messages, and we looked at correlation between those number of messages and the IOMD. And in each case, it was shown that there was a strong correlation between those two things. So increasing those number of messages meant an increase in the likelihood that you were in a high IOMD or a large chance of being in a deprived area. And also strengthening this correlation was the fact that the background system messages showed no such correlation. So if we can move on. We also looked at a few different time series analysis. So we looked at time series to remove the seasonal trends and look at predicting and modeling the overall trends of the system messages in terms of top up and disablement and emergency credit. And we also looked at device level prediction, which will allow us to look at those people who are behaving outside of the normal model that you would expect, and so enable us to detect whether people are moving into fuel poverty over time.
Great, thanks very much, Tom. So yeah, this initial research phase has really helped us to identify some really good data science opportunities and some better ways of spotting households that are moving to fuel poverty. And we really want to leverage that now into the alpha prototype that we're building out. So this is utilizing USmart, which is our data innovation platform. And there's kind of two core components that we've sort of built out within the alpha phase. So it's the need to develop an interactive map to explore that data analysis, and also to the ability to download historical data in bulk downloads. So USmart offers both. So we've got a kind of a data management piece, as well as a map interface tool, which allows a user to go through and select specific areas that they want to interrogate, as well as download sort of raw data as well. So there's two core components to the solution. Just to kind of talk you through a little bit more detail on the mapping side. So we've got a kind of an area to the left, which allows you to search and filter specific areas across specific time ranges, display the visualizations of the data analysis that we've developed, as well as on the map view, turn on different data layers. So from climate data, census and EPC data, and then also the data cards, which provides more detailed analysis that Tom kind of took you through earlier. So this is kind of, effectively providing a solution for both sides, raw data as well as data visualization. So as well as developing the alpha, we also wanted to look at the future benefits and Connect to Places Catapult supported us through developing a specific work package around future benefits evaluation and a framework around that. So there's an extensive report that they've developed for us, but to kind of summarize some of the sort of key components were really around the potential for more cost-effective public expenditure, better targeted retrofit solutions, and that will obviously help to stimulate the retrofit industry. So a huge opportunity for more jobs and more value add. There's also significant NHS cost savings as we improve the livability of our homes and reduce the cold-related illnesses that are attributed to cold homes, as well as fewer deaths. And also to really link with improving policy as that's being developed. So to ensure that these new models are kind of built into the policies that developed. And then ultimately to reduce fuel poverty, reduce our carbon emissions and help towards our net zero targets, which is the ultimate goal. So just some of the other key insights that we also look to really identify within phase one is around the open ecosystem within the energy data space. So one core component was to ensure that we really understood the user engagement. So we did that very well with Connect to Places Catapult and ensure that we're co-designing our solution. Another area was with the Energy Data Task Force. Can I just hand over to Heather, who'll just talk through a little bit more detail around some of the work that was delivered for that component.
Thank you. So the Energy Hub, together with 2 of our local authorities, went through the triage process on data collection, which is going to be relevant to both the LAD phase 1 retrofit that's been in flight for a while, and also the LAD phase 2, which we're just commencing. And really, I think we made quite a lot of progress in terms of understanding how we could share data into the project, given lots of GDPR and personal data kind of sensitivities. And I think we're actually, by the end of the process, very pleased with actually there would be lots of potential to share data about retrofit and help improve the sort of learning and findings and refine the tool as we move forward. And LAD phase 2 has been including permissions in terms of the project being able to access data as we move forwards. Thank you.
Great, thanks very much, Heather. Yeah, so I think that's really exciting to see as that's evolving. And then also the 2 other sort of core components that we've fully documented all the code development and it's been containerized and can be shared as required. And then also we've engaged heavily with the Open Energy portal, which is in development, and we're a beta tester of that. And our goal is to be a prosumer, so effectively to consume data and also to provide open outputs where possible. Great, just the last couple of slides. So really the kind of key insights really for the demand in phase 2 is we've already had interest and from energy companies and network providers. So SSE are joining our phase 2 proposal as we want to build out some of their further use cases. BEIS are also very interested in, from the fuel poverty team, have demonstrated a clear interest to see how the outputs evolve and develop and how that can inform their policy. And as I said, yeah, we're looking at more use cases within the energy sector. And we can see significant market potential for this data-driven innovation for a number of customers. So from local authorities, the energy hubs, energy companies, networks, utilities, as well as managing agents and central government and other charities to support the rollout of these interventions. And just the last slide, I think this is a really key insight. Just wanted to share this one from Tanya Jennings from the West London Green Homes grant that she's looking to deploy and to identify homes that are most at risk. So she's got a list of 250,000 homes and she wants to know which ones are the ones to target first. So this is really what we're really trying to help to solve with this project and this program. Great, thanks very much. That gives you a quick overview of a very intense 3 months of work, and look forward to having your questions.
Thank you, Simon, and thank you to the team for this super nice, super interesting, super fascinating project. We have 2 first questions here. One from Jonathan. You have partially answered this question, but do you look at building performance in your analysis? The biggest impact will be, of course, to target those who live in fuel poverty and in purely performing buildings.
Yeah, that's a good question, and yeah, definitely that's one of the sort of interesting data sets. It's obviously not a complete data set from the UK. I may pass over to Ellen actually, because the work they've been doing at Searle is super interesting and really utilising this data set.
Hi, thanks. Yeah, so we used energy performance certificate data as part of our modelling. For phase 2, that's really something we're going to build on. We're hoping to incorporate smart meter energy data. We're doing other work as part of the project, Searle, rather separate from this project, that will be looking at how efficient buildings are in terms of how they operate. So we can incorporate some of our learnings from that to see kind of underperforming households, incorporate that into how that affects fuel poverty and links in with that. That answers that question.
Yeah, great. And I think just one other point to make, ultimately our goal is to, as the interventions are put into households, and then we look at the impact, the way the impact is currently assessed is effectively looking at a new EPC certificate. And obviously what we want to try and do is see whether we can start to look at if there's any real-time data from the smart meter system data that starts to confirm some of the improvements as well. So that's really into phase 2 that we're looking to explore that opportunity.
Thank you for this. Second question is, how are you validating your predictions? Do you know how many false negatives you have? And with false negatives, meaning failure to indicate fuel poverty when it is present?
Yeah, that's a deep question, that one. So I think it's obviously within our initial phase, our first 3 months. I think we're still looking to further validate that. Maybe Tom, you can just talk a little bit about what we've done to date, and also what we're hoping to do in the future. I'll come to Alan.
Yeah, so mostly we've been looking at kind of feature extraction at the moment, and in terms of looking at the message types and seeing if there's a correlation between that and the IMD, using that as a proxy for poverty metric, and then once we found these features, using them to kind of look at a more time series based analysis. So given the history of the device, how is their behavior changing over time? So there's a few components here looking at deseasonalizing the data and building models over that data, but also using those models to kind of find people who are outliers. And so people who are in otherwise similar situations to everyone else, but seemingly increasing the number of messages or some other kind of behavior, so that, given that increased number of messages correlates with IOMD, it would be likely that these people are moving into fuel poverty, especially if they haven't been exhibiting similar behavior in the past. I think that's kind of where we are at the moment, basically.
Yeah, thanks, Tom. And Ellen, do you want to talk a little bit about some of the sort of plans into phase 2 for validating?
Sure, yeah. So that's an exciting part for phase 2, in that in phase 1, we weren't able to join up any of the Searle data with the data Urbantide have. So in phase 2, we're going to be applying to access this metadata from the DCC for our 13,000 participants. So we have a lot more data about these people than Urbantide did about the many more people they had in their data set. And so we would be able to identify the patterns that Urbantide have so far identified to predict fuel poverty, and then consider how that manifests itself in our population, in our sample. So do we find that where they believe there's a lot of fuel poverty, we also have predictors for fuel poverty from our household survey, from the EPC, from the energy they use, from their tariff data, or other people they're missing, as you suggested, there's people that we would identify in fuel poverty based on a number of factors that their model doesn't pick up. So in joining up these data sets, we're able to kind of validate and provide some context for the work that Urbantide is doing, and potentially feed in to improve their modeling.
Thank you. And we have a correlated question. This has just been posted in the chat. It is, given the strong correlation of the smart meters data with the deprivation index, do you actually need the smart meter data to identify fuel poverty?
Yeah, so the essence really is the smart meter system data provides a much more up-to-date, more real-time ability to understand in much more detailed level the different households and some of the outliers as well. So it really just adds greater detail. You know, we're kind of getting into the greater granularity of information here, and that's really one of the sort of the great opportunities that we really see with the DCC data. Matt, have you got anything else to add on that one?
I think, as you said, really, you know, this is a data set based on actual consumer behaviours as opposed to a model data set, really. So yeah, some clear advantages and yeah, dynamic and abilities to see those changes day to day, really.
Great. We have another question. It is, how have you, or are you planning to extend your approach to incorporate decarbonization of transport as well as heating? Or in general, how are you considering the whole system approach or implications?
Yeah, that's a really interesting one, I think. So a simple answer is yes. Obviously in phase one, we've really focused on the specific identification use case. And then as we kind of broaden out into phase two, into the intervention and impact, and then also bringing in other data sets. I mean, I know, Matt, you've already started to look at some other use cases of the smart meter system data that kind of align with the transport space around electric vehicles. You got anything to add on that?
Yeah, no, thanks, Simon. I mean, it's probably worth just mentioning that the smart metering system is currently the preferred option to support EV smart charging to allow that kind of mainstream adoption that's needed. And so there's inherent capability built into the system that enables that secure load control required for EV smart charging. So, you know, further down the line, the opportunity to then use the data flows and data generated from that development are quite clear and quite exciting, and you could see very much a way in which those additional data sets could be incorporated. I think there's also some really interesting a kind of interesting body of work developing in relation to transport poverty and the correlation between fuel poverty and transport poverty. So really interesting area for sure. I think it's slightly further down the line, and yeah, in terms of phase two, it's unlikely that the volume of data through EV smart charging through the system is something that we could pick up, but certainly one to keep an eye on.
Yeah, great. Yeah.
Sorry, Simon. Sorry.
No, I'll let you go to another question. I think you've answered that. Well.
Since Matt was already speaking, I will ask one question that has just arrived in the chat. It is, how long have you been developing this work, and how long did it take to get DCC and Ofgem approval?
Yeah, sure. I mean, so we've been working on a kind of wider program of smart meter system data access for a while, probably sort of 18 months, couple of years. And having a really compelling use case to hang on has been really important, and so certainly participating in this project has really helped to accelerate and work through some of the issues and challenges. In terms of getting Ofgem approval, I'm pleased to say it was surprisingly quick, actually, and you know, we worked with them, and they wrote a formal letter of approval just in the lead up to participation within the project, which was yeah, really helpful.
Yeah, I think just to sort of echo that. I mean, I think it's really having a fantastic use case like this, and also having clear hard deadlines. You know, very short phase one really helps to quicken the pace. So so that's a good way of delivering as well, delivering on these needs.
Simon, thank you, Matt. Yeah, we have one last question that we haven't answered. That is related to what we discussed before. That is, will you use the data from historic fuel bills to look at the building performance once a retrofit measure have been implemented? You already mentioned this briefly. Maybe.
Yeah. So a little bit. We obviously, with the smart meter system data, we're not getting actual energy usage. We're only getting, we get understanding of different message variants and how often the frequency of those. But linking it with Ellen's work at UCL, they have much more granular information around individual households. So maybe Ellen, you can just talk a little bit about that.
Sure, yeah. So we have half-hourly smart meter data, which we can then, sorry, what was the question?
The question was, will you use the data from historic fuel bills to look at the building performance once retrofit measures have been implemented?
Yes, so we have the potential to do that with SERL because we collect data from when our participants sign up back up to a year previously. And then we have the energy and gas data if they have gas. And we also have tariff data, so we can see what people are using and how much they're actually spending on their energy. And because we're tracking that through time and we have a couple of years worth of historic data for our participants, we can then, once a retrofit or something happens, we can compare what happened previously with what's changing. So that's a really great aspect of our project.
Yeah, and obviously that's what we want to validate against and combine with as well. So yeah, it supports our, yeah, it's a win-win.
Great. So thank you, Simon. Thanks to the team. And we need now to move forward with our schedule. We have a 5-minute break now. We will be back at 10:50. And please, if you have other questions for Urbantide, drop them in the chat. The team is online. They have access to the chat. They can answer through the chat. Thank you.
Thanks, everybody.